Hi, this is Mrs. Bazin, and in this screencast we're going to talk about dimensional analysis. All dimensional analysis is a fancy name for a problem-solving method that we can use to convert between units using things called conversion factors. This is also called factor label method. That might be another name that you hear it called. But what we're going to refer to it in here is dimensional analysis. Now, I know that you guys know how to convert between, say, metric units by just moving the decimal place. The reason we learn how to do this particular problem-solving method is because eventually we're going to be converting between things like atoms and moles and grams, which are units that you cannot move the decimal point to convert. So when we use dimensional analysis, we use things called conversion factors, and all these are ratios of equality between two different units. So they're also sometimes called equivalent statements because the two things are equal to each other. So some that you might know already are 4 quarters equals $1, 1,000 meters equals 1 kilometer. Some other ones that you might know, 100 centimeters is 1 meter. You could even say something like 1 dozen equals 12 units. So those would all be some conversion factors. Now, one that you don't know that we'll talk about a little bit is 1 milliliter is equal to 1 cc, or 1 cubic centimeter. A cubic centimeter, you usually see that on a medical syringe. So when they draw up, say, 5 cc's of a medication, that's equivalent to 5 milliliters. So you could use a syringe to actually measure volume. So what we're going to do is go through the steps. You don't necessarily need to write these down, but this just kind of is an overview of what we're going to do, and then we'll do lots of example problems. So the first step is you use the conversion factor that relates the two units that you're trying to convert. Now, sometimes you're converting, you need more than just one conversion factor to get there, and we'll see some examples of that. The next step is to multiply what you're converting by the conversion factor. Once you have your answer, you're always going to go back and round to the correct number of sig figs using the number that you were given originally, or the measurement you were given originally. And then finally, one of the most important steps here is to make sure your answer makes sense. So take just a minute when you get finished and look at your answer and make sure that number makes sense for what the question is asking. So let's look at a couple example problems. So our first example is how many centimeters are in 2.78 meters. And again, I know you know how to just move the decimal point, or some of you could even do this in your head, but let's use this simple problem to practice the method. So we have 2.78 meters. And again, we're always going to start with what's given in the problem. Okay, now we know that there are 100 centimeters in 1 meter. So at this point, we do have a direct conversion between meters and centimeters, so this is only going to require one step here. So whatever I want to cancel, which is meters, which is right here, I want that unit to be on the bottom of my next bracket. So that's where this is going to go. So 1 meter goes on the bottom, and the unit I'm converting to, which is centimeters, I want to go on the top of the bracket. So 100 centimeters goes on the top. So then, as I go through, whatever is on the top here and on the bottom here cancel out, and then I'm left with the unit that my question is asking me to find. And if this had multiple steps, you would keep going with these conversion factors until you end up with the unit that the problem or the question is asking for. So once we've done this, now we're going to do the calculation. And when you do the calculation for these, what you do is you multiply going across, so anything in the same line going this way you multiply, and then we divide top to bottom. So we take the top divided by what's on the bottom. Now here we only have 1, so we don't have to really worry about that. Okay, so let's go ahead and go back and do our calculation here. So we're going to take 2.78 times, and I'm going to write this one out just so we can see how this works, 2.78 times 100 divided by 1. So when we multiply that out, we end up with 278 centimeters. So this would then be our final answer for this one. Okay, so let's look at another example. So our next example is how many grams are in 0.984 kilograms. So again, I'm always going to start with the number they give me in the problem. So 0.984 kilograms. Draw my chart here, conversion chart, or or whatever you want to call it. And then I'm going to think of, do I know a conversion factor that directly gets me from grams to kilograms? So I know that 1 kilogram is equal to 1,000 grams. So when I put it in to my next bracket here, kilograms I know has to be on the bottom because that's what I want to cancel out. So this is my kilogram part of it. So 1 kilogram goes on the bottom. 1,000 grams goes on the top. So then I can go through and cancel out my units to make sure I've got everything set up the way I want. So kilograms cancels, and then I'm left with grams as my final unit, and grams is what the question was asking me to find. So now I'm going to multiply going across, divide top to bottom. So my final answer here is 954 grams. And again, our last step, like we said, we're going to check for sig figs. So my original number here had 3 sig figs, so my answer also should have 3 sig figs. And in this case, I didn't have to round. I just ended up with the same number of sig figs. And like I said before, again, make sure your answer makes sense. So we know that grams should be a larger number than the kilograms, which that's what we ended up with here. Okay, another example problem. How many seconds are there in one day? This one's going to take a few more steps than what our previous ones did. So just like always, we're going to start with what they give us. We're going to start with 1 day. And then we're going to go through with our conversion factors until we end up with seconds. Now, I tried to discourage you from creating your own conversion factors by multiplying conversion factors before you put them in. It's easier just to go step by step and put the conversion factors in as you go instead of trying to multiply or create your own conversion factors, because sometimes you end up with errors as you do that. Okay, so days is here, so I want days on the bottom. So my first conversion I could use is that there are 24 hours in one day. Okay, so days then cancels. Okay, now I'm in hours, but I need to be in seconds. So my next one, now I need to get rid of hours. So I know that 1 hour has 60 minutes. So now hours cancels. Next step, I need to get rid of minutes. So I know that 1 minute has 60 seconds. Okay, so minutes is now gone. I'm left with seconds, which is what they're asking me to find. So now I can go ahead and do my calculation. And again, I'm going to take 1 times 24 times 60 divided by 1 times 1 times 1. Now, you're not always going to have ones all the way across on the bottom, but that makes the math on this one pretty easy. So when I go to calculate this, I end up with 86,400 seconds. Now on this one, because days is more of a counted number, we said it has an unlimited number of sig figs, so we're not going to worry about sig figs on this particular one. And if we think about it, this does make sense because we know there's going to be a lot more seconds, and this number should be a lot bigger than the number that we started with. Okay, last example problem, if you need to see one more. How many kilometers are there in 6.2 times 10 to the 7th centimeters? So this will also give you a little bit of practice with using some scientific notation with your calculator. So just like always, I'm going to start with what's given. So 6.2 times 10 to the 7th centimeters. Draw my conversion chart. And now I'm trying to get to kilometers. Now I don't know a direct conversion between centimeters and kilometers, but I do know how to get from centimeters to meters. So centimeters needs to go down on the bottom here because I want that to cancel out. So I know that there are 100 centimeters in 1 meter. So that cancels out my centimeters. Now I'm in meters, I need to be in kilometers. And again, I know a conversion factor for that. I know that 1 kilometer is 1,000 meters. And again, meters has to be on the bottom because that's what I want to cancel. Kilometers is what I want to end up with, and that's where I'm at, so I know that I'm finished putting my conversion factors in. Then I go through and do my calculation. So now I'm going to take 6.2 times 10 to the 7th times 1 divided by 100 times 1,000. Now when you do this all on your calculator, if you try to do it all in one step, the best thing to do when you hit that divided by button is to put parentheses around all of this stuff on the bottom. that usually works out a little bit better if you do that. The other thing to look at on this one is when you put the scientific notation into your calculator, it's better to not hit times 10. The easiest thing to do is to use the scientific notation button on your calculator. So when you plug this number in, you would put 6.2 EE7. So you wouldn't hit times, you wouldn't hit 10. When you use this EE function on your calculator, and I can show you that in class if you can't find that at home, this replaces times 10 to the 7th, and that will usually, sometimes when people use the times 10 button, they end up with extra decimal places if it's not used correctly. So the safest way is to use this EE button, so 6.2 EE7 times 1 times 1 divided by, parentheses, 100 times 1,000. And if all of that is done correctly, you should end up with 620 kilometers. Checking sig figs, our original number had 2 sig figs. So our final answer should have 2, which it does, and logically that answer makes sense.